Greetings all, and welcome to our Discover Cal on Artificial Intelligence. My name is Howard Heavner, and I'm the Executive Director of Annual Programs here at UC Berkeley. First, a few housekeeping items. If you'd like to ask a question of one of our speakers this evening, please submit it using the Q&A feature. I'll take a few questions following each speaker, and as time allows, after all of their presentations. The program tonight will run similar to a TED Talk, where we have given the faculty a short time to present their work. The speakers will try to respond to as many questions as they're able as well. We're really excited to be able to showcase some of the Cal's amazing faculty to you this evening. Tonight, we'll discuss artificial intelligence, or AI. We'll cover everything from new technologies, how AI can help the environment, and the ethics of AI. I don't know about you, but my first introduction to AI was in my early teen years reading Isaac Asimov books. As it was wont to do, my imagination ran wild with the vision of what the future could hold. And now, as we are in this future space, it's exciting to learn what the term actually means today. I'm incredibly excited to hear from tonight's speakers. I want to take a moment to thank you for your amazing support of Berkeley. We're proud to offer this program to the members of the Charter Hill Society and the Wheeler Society. You are among Cal's most loyal supporters, and that means the world to the campus. Thank you for your continued support to help Berkeley light the way. Before we get started with our amazing faculty, I'll give you a quick campus update. As always, there's a lot going on at campus and a lot to be proud of, even though it may look a little different this year. The biggest news of the day is our virtual student experience this fall. All of our classes are currently being held remotely, and the campus is certainly quiet without the normal busyness of Sproul Plaza or packed lecture halls. We're planning to have much of the spring semester as virtual as well, but we are actively working with the city of Berkeley to allow some small in-person classes. Students will not be required to be on the physical campus for their classes for the spring semester, but we're working to figure that all out. In more exciting news and positive news is today, U.S. News & World Report ranked Cal as the #1 public university and the #4 overall. We're incredibly excited to hear this news and to have that ranking. The fall semester is different than most, and we do expect to have our first football game without any fans present on November 6th. We're working with the Pac-12 for similar schedules and plans for basketball and the Olympic sports. I've been asked to remind everyone that no fans also means that the campus parking lots and Tightwad Hill will be closed for game days. If you're planning to watch the Bears, please plan to do so from the comfort of your own home. Earlier this month, the campus had the great delight in celebrating not one, but 2 new Nobel Prizes on campus. Professor Emeritus of Physics and Astrophysics, Reinhard Gonzalez, was awarded the Nobel Prize in Physics for his research in the discovery of a supermassive compact object at the center of our galaxy. The second was a Nobel Prize in Chemistry, awarded to Professor Jennifer Doudna, the Li Ka-shing Chancellor's Professor of Biomedical Science, for the development of a method for genome editing that has led to the amazing CRISPR research. Jennifer was the 25th Nobel that the campus has received and the first female faculty member to do so. It has been really an exciting month and with these great honors. Congratulations, Professors Gonzalez and Doudna. With that, I'm very excited to get started on tonight's topic. We have a fantastic variety of speakers who will speak briefly about many different aspects of artificial intelligence and give you just a brief tease of the amazing work Berkeley is doing in this area. It's now my pleasure to introduce our first speaker for the evening. Ruzena Bajcsy is the NEC Distinguished Professor of Electrical Engineering and Computer Sciences. She is also the founding director of the Center for Information Technology Research in the Interest of Society, otherwise known as CITRIS, in 2001. She played a founding role in establishing a program of digital humanities. Dr. Bajcsy's current research is in the use of robotic technology, namely measuring and extracting non-invasively kinematic and dynamic parameters of individuals in order to assess their physical movement, capabilities, and limitations. That is just a mouthful to say, and amazing to hear her talk about these things. Professor Bajcsy, please share your slides, and we're happy to have you here.
So good afternoon, everybody. As I mentioned before, I have been in this AI business for 60 years, so I have lived through all these variations of ups and downs in AI, artificial intelligence. And initially, I worked with John McCarthy, who was my advisor, and he was always dreaming about that we will eventually try to understand what what intelligence is, but I should say to you that we are far from that. We don't understand too well the intelligence. However, little by little, we are getting to some aspects of the intelligent behavior. So all my life, what I have been trying to do is to understand the physical intelligence, how people interact with the environment, and can one build machines that would collaborate with people and help them? That was my goal for the last 60 years. And that's what I'm going to show you. Few snippets from my students who are actually doing the work. So think about it. You have here a motivational slide here that you see that people are carrying heavy objects and simple heavy manipulations that machines can help. So this is an Aaron Bestick who finished his PhD in 2017, and he here examining how to collaborate with the robot. Now, those of you who are more technically tuned to this whole area of robotics understand that each of these joints have rotate in 3 dimensions. So each translation X, Y, Z and rotation theta, phi, alpha gives you 6 degrees of freedom. Now, the same way, in order to have a formal model, you have to also be able to understand human capabilities of how they move with respect to the robot. And therefore, you have to be able to measure. And here we have these markers where with camera we can detect at least, how the individual joints in the limb and how the individual human is moving and therefore collaborating. So that's sort of the idea. Now, in order to, the previous slide shows you that what we call is how you can control kinematics, which is velocity and position. So depending how you move, and you should also remember that depending on the object, whether you are picking glass or you are doing a screw driving, the motion and the interaction will be different. So therefore, you have to have some more generalized ways of detecting the velocity and position. Now, in order to understand the dynamics, and those of you, so we really need to understand the forces. And indeed, I have a student, Lori Hallock, who has been for the last 4 years studying muscles, because the muscle in your body is actually that motor, that engine that exerts force. So we have been, and of course, we are focusing on non-invasive way of measuring that. So here is a setup where we are using ultrasound measurements on trying to detect how much the muscle stretches or contracts. I will show you some examples. So here is the ultrasound picture that you can detect. And this is, but as you can see, it's not a nice ellipsoid or it's a regular geometric structure, but it's this funny structure of the muscle. But indeed, we can detect the change in this shape of the green, which has no force, to a maximum force, which is the red one, okay? So, and then, if you really want to look at it with respect to the human arm, so the muscles change depending on whether you have which angles of the configuration is, and therefore you can see these red segments of the muscle. We can detect segment and measure how they change from the no force to high force. So now going to next slide is Caroline, Caroline Mattel, who has been working and trying to understand Turing. And how can you, from detecting your velocity on your wrist or in your robot, to detect that? How much? So let's hear. I hope you detected this properly, but the idea is that we want to measure how this interaction of this, the arm or the robotic arm or a human arm, how does that, can we measure the physical parameters so that then eventually we can control it. And as you probably know from the news, that people are talking about robots helping in the kitchen. So if that's what you have to do, what you want to do, then you have to deal with operations such as pouring, as it is shown here, or in the middle was having, like, let's say, material like liquid is very different in viscosity, physical properties than, for example, flour or salt or sugar. So, you know, and you have to understand how they physically behave so that you can build the robotic system to deal with that and help the human. And similarly, on the last window, you have a dough. And a dough is a very interesting material because it can be deformed, but it depends on how much water you put into the flour. That will, you can control the elasticity and the plasticity of the dough. And that's why you can make from a dough, you can make a bread, or you can make a pie chassis or so forth and so on. So that's what really this problem is all about. And what you really want is to extract these parameters so that then you can put them into the computer and control the robotic arm and help the human. Okay, so because we are so interested in in contact sensing and tactile sensing, of course, vision is important, and many of our colleagues have been working on visual information. But my group has been focusing on tactile because we are interested in manipulation. You know, your hands are very tactile sensitive. So we built a camera here, depth camera with one tactile sensor, which has elastic surface so that will deform depending on the hardness of the object. And we can measure through the camera the displacement and therefore derive what the hardness of the object is and how hard we should press or not press. So I'm afraid that, so, so then we are, the student is looking in tactile sensor and can control even very curved surfaces. That is very important in many other applications. So here, I'm not sure whether I know how to make this play, but okay. All right, so let me just go back now. I want to show you, just a second. Okay, here we are. So I am also a dedicated, do you see this? Or
No, Professor, we can't see it.
You can
You
see.
have to share
Okay.
that.
Good.
We just see your, no, we see your PowerPoint, Professor. We need you to share the screen that has your video
Oh,
on it.
share. Okay, sorry.
Yeah.
I apologize.
Okay.
So we need to share.
It's okay.
Okay, so I have to stop sharing and then go back to sharing. Yes.
Yeah, share the video.
Okay. I'm coming back. Yes. All right. Technology. Okay, good. All right. What I wanted to share with you, and this is less research than really application for teaching. I have been very concerned, ladies and gentlemen, that the course which I taught, which was an introductory course to robotics, I had about 180 students and they loved them. Of course, we had labs every week. They could go down to the lab and test, and program these robots to move and grasp and push and pull and so forth and so on. And now, what can they do? They can just stare at the professor. I'm not teaching anymore, so Shankar Shastri took over my course. But anyway, that's all. So the only thing they have visual information. So I have been very concerned that the kids today don't get enough physical information. What it means: hard surface, soft, deformation, elasticity, fluidity. All these basic Newtonian physics concepts. So I set up with a colleague of mine, who's an electronic engineer, and we started to build, and this is just a very beginning prototype, we started to build a tactile display. The idea is that you saw my student has developed this tactile sensor, so we can measure how hard the surface is or how deformable the surface is and all that. But then we can send it just like we send visual information, this information into this gizmo that you see, and based on the amplitude of the data of the force sensor, the individual pecs will be moving just as they are moving here. So this is sort of just a prototype. This is not a new idea, but I was really interested to develop something like this for students for $150 so that we can then make it in the larger numbers and send it to them home so that they can learn how to feel the environment rather than just see. So this is my device. So I'm really very committed to the well-being of our students because that's our future. Thank you.
Yeah. Well, thank you, Professor Bajcsy. We have time for one quick question, and so the question that came in I thought was really interesting. Is that you've been, of course, in the field for 60 years, and
yes.
And the question was, do you think innovation in this space is happening at a faster rate, the same rate, slower than earlier in your career? Like when you think about in your start of your career to now, it feels like we've sped up. Have we sped up?
Favorite subject of mine, yes, because I've been there. So let me just tell you my prejudicial way of thinking about it. We were dreaming, ladies and gentlemen, in the 60s when I was at Stanford at the AI lab. We were dreaming about all these things, okay, but we didn't have the compute power. We didn't have the memory. We didn't have internet in the late 60s, okay? And let me tell you, folks, when I took my first job as an assistant professor at the University of Pennsylvania, I built my own digital camera because there were no digital cameras available.
Right.
Okay.
Yeah.
So frequently the AI software people don't give enough credit to our hardware colleagues who developed all this hardware technology that now facilitates that we can store all these gigabit data and do the big data stuff, okay? Which of course we couldn't even dream about it, right? We can run robots in almost real time. We can control 30 degrees of freedom, which it was impossible to think about it. So The hardware on every level has changed. And with that came all these smart students and developed all these new programs and so forth. Now, the fact is that I have to tell you that the speed right now, the progression is much faster now because the industry sees the value. In those days, we were dreamer, just like I am still today a dreamer, okay? All right. Yeah. We were dreaming, and that's what academia should be. We should be dreaming, okay? But the industry has picked up things that worked or don't work, and they run with it. So, yes.
That's fantastic, Professor Bajcsy. I thank you so much. We only had time for one question, but thank you so much for sharing some of the work and just your perspective and the history you have with it. It's just amazing. So just grateful to you spending some time with us. And so,
I am lucky to have very good students and colleagues, but really students at Berkeley. They are outstanding. And I thank everybody who sends their kids to Berkeley.
That's fantastic. Well, thank you so much. I appreciate it. We might have some more questions for you. I think there's at least one more question in there that maybe you want to try to address, and actually,
sure.
My colleagues can probably help you do that if need be. Next, we're going to move on and to our next presenter, and I'm excited to introduce Jordan Diamond. And Jordan is the Executive Director, Center for Law, Energy, and the Environment at Berkeley Law, as well as a law school alumna herself. Jordan channels the expertise and creativity of the Berkeley Law community into a pragmatic policy solutions to environmental and energy challenges in California and across the nation. Tonight, she'll speak to us about AI and the environment. Jordan, I'm going to turn it over to you.
Fantastic. Thank you so much, Howard.
Thank you.
I will do my best to start slides. Okay. How does that look?
Looks great. We're all set.
Fantastic. Well, hi, everyone. Thank you so much for joining us tonight. Thanks for the invitation to be part of this panel. And it's a pleasure to engage in the conversation. And also, Professor Bajcsy, it is humbling to follow you and the path that you have carved in this incredible area. As Howard mentioned, I'm Jordan Diamond, the Executive Director of the Center for Law, Energy, and Environment. If you're not familiar with our center, we are an in-house policy workshop within Berkeley Law. We work on developing pragmatic, real-world policy solutions to the environmental and energy issues that threaten our future, our collective future on this planet. We are mostly, but certainly not all, lawyers, but we specialize in working on cross-disciplinary teams that incorporate a wide range of perspectives in order to craft holistic solutions. And we get to do this within the #1 ranked environmental law program in the country on the campus that pioneers some of the leading research on the thorny issues that we work on. So it is a privilege and often humbling to be affiliated with the university, especially right now. As for why an environmental lawyer is on this panel, I will confirm that indeed I do not know the first thing about developing artificial intelligence, absolutely nothing. But for the past several years, I've been working with colleagues at Yale University and the Environmental Law Institute in DC on an initiative looking at the environmental and energy impacts of the digital economy, including artificial intelligence. My partners and I think about the direct and indirect impacts and the beneficial applications on energy and the environment. Our core goals are to stimulate research and focus on the intersection with the environment. So we've provided seed funding to researchers, work to connect them across disciplines, and generally are striving to develop this as a field of practice so that we can, in fact, maximize benefit and minimize harm. A few examples of what we mean. Recognizing at the outset that people have often joked that non-engineers often call any piece of software artificial intelligence. But let's start with our behavior and activities on the road. So we rewind a few years to the VW diesel emissions scandal. I had a so-called clean diesel, Jetta Sport Wagon. Now, if you recall, it turns out the diesel was not so clean. Rather, it had a cheat device installed that helped detect when the car was in testing mode, at which point it would turn on various mechanisms to reduce emissions below mandated levels. But when not in testing mode, the control shut off and emissions would reach up to 40 times allowable levels of nitrous oxide and other pollutants. This was simply an intentional bad act. But I mention it because now contrast that with the reverse. Imagine a car that analyzes circumstances, conditions, and driver preferences, and then adjusts operations to actually achieve better environmental impacts. Imagine if the car were continually making decisions, so to speak, about what settings to use in what circumstances to maximize energy savings, fuel savings, safety, or whatever other factors you prioritize. And then you can take the next steps to think about self-driving cars and the thousands of decisions being made about routes, speed, safety, et cetera. Or you can think about ride-hailing apps and right now the directions that they give to drivers and the shared ride choices being made. What if all of these systems actively considered emissions and their overall environmental footprint in their decision-making? So what if we weren't just hoping that ride-hailing would someday lead to a reduction in vehicle miles traveled, which it has not so far, but rather we programmed emission reductions into the underlying architecture as an explicit goal. Or we can look inside the home. Our devices and appliances are increasingly connected, and some of this is sheer convenience. It's convenient to be able to turn off the thermostat from down the road when you forgot to turn it on before you left the house. But while they make us feel smarter, that device isn't actually fundamentally operating any differently. But then take that next step, looking at some of the thermostats today, such as Nest, that look at behavior patterns and adjust accordingly. What if your home appliances and systems were working in concert with one another to actually maximize sustainability at any given time? Making the decision about whether it's better to say run your dryer or turn on the air conditioning at a certain level based on factors such as demand response on the grid or balancing whether it's sunny out and the grid is likely to be heavily powered by solar at that time, or when to run the dishwasher or water the garden depending on forecasted rainfall, etc. And then you can look online, which since the pandemic started is, of course, the only place we've been going. We've seen significant upticks in online shopping. For anyone who bought anything on Amazon Prime Day recently, Prime Day sales rose roughly 45% year over year and almost 150% going back 2 years. Now, anyone who has ever purchased anything online is familiar with the suggestions and you might also like items that will then pop up the next time you're online. But what if those algorithms were programmed to incorporate sustainability goals, to interpret shopping behavior and supply trends and even shipping routes and determine what more environmentally friendly purchases or actions you might be open to? Further, do you need that toddler Halloween costume? I say with 2 toddlers in my house who are very worried about their Halloween costumes. Do you want to get it on Tuesday, or can you wait until Wednesday if that means you can actually get more sustainable or recyclable packaging? Or is there a shipping route that avoids sensitive marine areas? I mean, the idea is there a way that you can actually, or that an AI system could actually know your preferences and scour relevant information to help you make more sustainable decisions? In addition to lowering the footprint of your purchases, could an AI system help you make better online selection generally? Measuring items you're less likely to return, thereby reducing the enormous increase we've seen in the return of items, many of which unfortunately go straight to the landfill. So there are countless other examples that we could give of both direct and indirect impacts. But there's also the other side, and I won't go into much detail because I believe some of my esteemed colleagues will go into this later in the session. But suffice to say that algorithms can embed and extrapolate biases, and most of us don't know enough to detect them. And then there's the fact that machines make mistakes. How confident are we that we don't need a person or a human referee involved to check the outcomes? Environmental and energy decision-making often carries very significant consequences. To use a timely example, AI is often cited as a possible solution to better helping manage the electricity grid to reduce power outages and catastrophic wildfires. So think of the liability associated with a wrong decision. Where does responsibility lie when we've programmed a machine to teach itself? I'd also like to note the asymmetrical development of our access to AI in the private versus public sectors. A 2016 GAO report noted that 75% of federal agency IT budgets are devoted to operations and maintenance of existing systems, leaving 25% for development, modernization, and enhancement. And on top of that, there can be public institutional barriers to innovation based on little reward but high risk if something goes awry. all of which suggests that the majority of AI innovation and deployment is occurring in the private, not public sector, which can leave regulation in the role of playing catch up. So all of these factors can make governance challenges significant. Policymakers, regardless of their technical expertise, must determine how to regulate and deploy these systems and/or how to consider them in legal settings and proceedings. And in a legal system, based on the concept of mens rea or the knowledge of the act of wrongdoing, where does an AI system fit in? So how do we, at the end of the day, maximize benefit? Okay, said screen sharing stopped, apologies. Well, I will continue. But at the end of the day, how do we maximize the environmental benefit and minimize the environmental harm? And this is the point where my law and policy nerd flag flies true and strong. And I get to admit that I get very excited about discussing process. So without going into too many details, I simply note that what I enjoy thinking about is first, in order to be able to address this, we need to be aware of the potential impacts. We need to be aware of the potential harms, of the potential non-obvious benefits in order to be able to take action. And that requires communication and communication between non-obvious actors, communication at the development of the new systems and throughout deployment to make sure that we are identifying potential unintended consequences as well as potential beneficial applications. And this is true for both technologies that are intentionally focused on the environment as well as technologies that aren't. And I would say the latter are often more challenging because that's not an automatic part of the system. And this all calls for adaptive management. So we need systems so that we can monitor, detect, and then adjust when we encounter unintended consequences. And this is both in terms of in the mechanics and the machine itself, so that we can adapt things so we can adapt, and also on the human side. So there's a process for that monitoring, flagging of issues, and then a determining of appropriate response. None of what I've just described is simple, none of it. But there are many dedicated and incredibly talented people that are making inroads, that are building governance mechanisms, developing protocols, centralizing contacts in order to make progress. And that's what keeps me talking to incredibly smart people who are entirely out of my league and actually creating artificial intelligence, trying to figure out how I, as an environmental lawyer, can help ensure that we do as much for the environment as possible. So with that, I'll thank you again for the chance to talk with all of you tonight and share a bit of what I've been thinking about.
Thank you, Jordan. That is, it's really another interesting perspective on the subject. You know, I know the question that occurred to me while I was listening to you was really thinking about, you know, I mean, Amazon's the easy one, but even the rideshare apps and the gig economy, right? Like, all those platforms are using forms of artificial intelligence now, basically to predict how we're going to behave as consumers. So is it really just, is it in part, I guess, to phrase as a question, what are the barriers to them to actually redirecting some of that already kind of, structured, intelligence gathering that they're using? Like, what's the barrier for them to not make the delivery process smarter, right? Like, what is it that's preventing them from doing those types of things?
Mm-hmm. So without, chooses are sounding too cynical. These are meant to optimize. I mean, they're supposed to reduce your ride length and reduce overall cost while maximizing profit for the company, right? So there are some very clear kind of incentives associated with this. In terms of the steps, I think this is one of the things that for me is a great example of why you want to have the conversation at the outset rather than trying to go back and revise the system afterward. Because now going back and actually changing the system is a lot more difficult than if you had actually built in some of these parameters from the beginning. And so we see this, that's kind of a common tenet of commenting or, and influencing decision-making period. It's much easier to be part of the team developing the system than asking them to go back and change it.
Yeah, that's fascinating. Well, I want to, there's a question here from one of our participants. So I want to make sure I try to present it correctly. So when thinking about, and this might be a little bit, I know because you're in environmental law, so this might be a little askew as far as, thinking about any recommendations or thoughts about how do you balance, the concern with, the things you're talking about, right? The concerns with privacy versus the optimization opportunities of AI, right? Like that balancing act, and any thoughts on that, or how do we as consumers, either protect ourselves or also push to get change made to have sure they're using the data in the best way possible?
Absolutely. So I have a few thoughts and a few comments with absolutely no solutions. So I will say, I think that's spot on. I think that's a critical issue. One, I will flag just how much information is already being used. And so without going further than we have already gone, I think that there are questions about what more we could already be doing or how we could deploy that information in other ways. Second, I think there's some interesting potential developments to be made in terms of how information is in fact stored or access to that information. And I've worked with some researchers without going into the details of what they've been doing, but how do you create a collaborative and shareable kind of vault of information, but that you still kind of own your information, which is incredible and far beyond my technological capacity. I will also flag the work of some of my colleagues within Berkeley Law, and specifically the Berkeley Center for Law and Technology, who has some leading privacy experts, and they also have some broad initiatives on artificial intelligence. And just to really flag their work, because they have some great people thinking specifically about these intersections. So I think that's an incredibly important question. And then the last thing I'll highlight is just the flip side of this information about you that is available to others. There's a huge question of how do you gain access to it? And so, for example, and this isn't necessarily AI, but your energy usage in your home, it is very difficult to get information about your own energy usage other than how much you used each month. But if you did have better information about that, how would you change your lifestyle, your habits, etc.? So this question of access to information, who has a right to it and who has a right to keep it private, I absolutely think I appreciate the question and think there's a lot of work to be done there.
Yeah, it's super interesting. I really appreciate. I'm so excited that you're a part of this, because it's such a kind of a different take on the subject. That is there's very pragmatic questions that are involved in what you're working on. So thank you so much. It was such an interesting talk. I think that you're part of this. There are some questions building up in the Q&A that may be appropriate for you to try to address if you want to. So hopefully you'll stick around and help us out with that a little bit. So thank you so much, Jordan.
Thank you.
Thank you, of course. All right. Oh, okay. All right, so our third speaker this evening is Joseph Gonzalez, an assistant professor in electrical engineering and computer sciences. Professor Gonzalez is a founding member of the UC Berkeley RISE Lab, which is real-time intelligence and secure execution. His research interests, okay. We're getting a little background. Can you mute for a second, Joseph?
Yep, I apologize.
It's okay. There we go. Okay, now I give you the appropriate introduction. So his research interests are in the intersection of machine learning and data systems, and his students are working on a wide range of projects, including real-time model serving, machine learning lifecycle management, model-based cloud resource management, software platforms for autonomous vehicle research. Professor Gonzalez, super excited to have you, please, and thank you.
Thank you. Let me know if the audio does have some issues. I'm hoping it'll be good. So I'm probably the more junior of the people here. I'm still an assistant professor. I do research at the intersection of machine learning and systems. As I said, one of the co-directors of the RISE Lab. I thought I'd start by saying, what is machine learning? It seems like a meaningful question to answer if we're going to talk about it. So machine learning is often also
Joseph, so sorry to interrupt. There's some background noise. I don't know if it's a video playing. There, it's better now. It sounded like maybe traffic on the freeway or something like that.
Let me do something. I apologize.
Okay. That's okay.
Can you hear me now? A little bit better?
Yes, that's better. Thank you.
Yeah, I apologize. Yeah,
thank you.
So one of the things we had to do to upgrade our teaching is have new audio equipment, and still getting it right. Anyway, so machine learning, what is it? Well, it's often called artificial intelligence, but it's really the ability of software systems to adapt or improve through experience through data. And so we've already touched on this a little bit. There's been an explosive growth in machine learning. And what do I mean by that? It's the new Moore's Law. So this is actually a plot of publications in machine learning. The papers we're supposed to be reading is actually outpacing our growth of the semiconductor field. So this is an exponential growth in publications, a lot of excitement in the field. And a fair question one might ask is why? So I've been in the field for a while, and I'd like to claim that the advanced are algorithms. And so you probably heard of stochastic gradient descent if you work in machine learning or adjacent to it. This is an algorithm from the 1950s, so that is not it. What else? There's a lot of excitement around neural nets, deep learning, or advancing our ability to fit to new tasks, advancing our modeling capacity. When did those come about? Where is this picture from? It's from the 1990s. So the core ideas that are advancing machine learning aren't actually from maybe the core areas of machine learning, they're from other areas. And Ruzena alluded to this earlier. One of the big things we're seeing is growth in data. So exponential growth in access to data, tools for processing data. The cloud has made it easier to process data at scale and to collect data sets like ImageNet. Some water. Okay. Very good. Compute. So that's the next thing. So we've seen a big growth in the amount of compute that we have access to. So the hardware people have made multi-core processors, many core processors, GPUs, accessible to researchers. The research started on gaming rigs, and now we have huge clouds of GPUs that are powering the research that we're doing and enabling a lot of these advances in AI. And then finally, abstractions. And this is something that often gets overlooked, but the software tools that power AI that allow us to express these models are getting easier to use. It used to, when I was a graduate student, you had to derive variational bounds, work through complex mathematics, the things we teach in these classes. But today, you can use basic Python code, and people with very limited backgrounds in machine learning or in statistics, even in computing, can build models to solve really intense new problems. So there's a lot going on. There is still advances in the algorithms and the models, but there's these confluence of major trends in data, compute, and abstractions that have powered or enabled this explosion in machine learning. So that was now, or that was the past into now. So what's the future? And so I'm one of the co-directors of the RISE Lab. And so in the RISE Lab, we're trying to think about where is the future of machine learning and systems headed, this intersectional study. And so we've been looking at the design of real-time, intelligent, secure, and explainable algorithms and systems. And this touches on some of the things you've already heard about. So problems like supporting fraud detection at banks, robotic surgery, high-frequency trading or financial markets, autonomous driving, which I'll talk about in a moment, or IoT devices that collect and operate in our houses, collect data and operate in our houses. So when I say real-time, I mean being able to respond in milliseconds, using sophisticated models and algorithms. When I say secure, we need to be able to protect not just the data, but also the models and our interaction with end users. I mean, another thing that's kind of emerging as we apply AI everywhere is, can we understand the decisions that we're making? Can we provide explanations for what the AI decided to do? Why did it choose to run through that intersection? So these are the dimensions that we're starting to explore when we think about the intersection of AI and systems. And one of the things I think is really unique about work at Berkeley is that we're doing this by bringing people together in backgrounds in AI, security, hardware, and systems. So really large collaborative efforts. And you'll see when we compare to other universities, that most of the publications here bring people, multiple faculty from multiple different areas, and in fact, even collaborations with the law school, for example, to address these kinds of problems. So really collaborative work. And so even within the computer science department, we have really tight collaborations with the big Berkeley AI research group, which I'm also part of, and Berkeley Deep Drive. Right, so that's kind of a high level picture of what we're doing in the RISE Lab and why we're seeing these explosions in AI and where I think we're headed. I wanted to just show a few vignettes of some of the cool things that we're doing to kind of give you an idea of where this work is going. So I alluded to real time, being able to interact, build cyber physical systems that can be powered by AI. Probably the most obvious one is systems for autonomous driving. We have real vehicles, but I'll show you what we're doing in simulation first because it's the safest place to do it. Starting to understand how differences in algorithms and interactions between time, accuracy, and models can lead to safer driving. The model on the right is running over a pedestrian, the model on the left is not. The model on the left is actually less accurate, but faster. And so understanding these trade-offs and being able to optimize for those allows us to build better, safer systems. And with that in mind, we do actually put people inside these vehicles, and let's go here. So this is actually our postdocs driving the car. Actually, well, their AI is driving the car with one of these real-time systems. I won't finish the video because I don't want to show how it ends. So that is our work on autonomous driving, building real-time systems. We also think about how to make systems more intelligent. When we look at AI today, we often think the same way with all inputs. Your neural net that classifies images is going to do the same amount of work when it sees a a blank screen as when it sees a really complex scene. So we want to be able to distinguish between hard and easy problems to apply resources and computation where they're most needed. And so this is kind of building on this Nobel Prize winning work on think fast and think slow, how humans approach the world. Can we bring that to AI? And I'll play a quick game, which may or may not work over Zoom. So I'm going to show you a picture. Was that a cat or a dog? You saw a picture, and probably if Zoom worked, you saw a dog. Let's do another one. Was that a cat or a dog? So hopefully this one was a little bit harder. So this is actually, it's not clear what this is. I believe it is formerly a cat. So you had to think harder about the scene, and we'd like to be able to capture that in our AI technologies. And we've been developing cascades or approaches of differentiating between hard and easy images that allow us to compute or spend less compute cycles on things that are easy and more compute cycles on the things that need it. And we can take those ideas and build them across networks, within networks. A lot of cool research, and I won't go into the details on those. Security is something that's often overlooked, and that's a big part of the RISE Lab, is how do we make these systems more secure? And actually, one of the cool things that we've been looking at is how to enable collaboration. So one of the crazy ideas is that with better security, we can actually unlock more data. We can solve bigger problems. So more secure actually means better AI. And one of the things we've been exploring is algorithms that allow us to bring parties together in a way where they don't have to share their data or they can't see the intermediate computation, but they can derive models and solve problems without having to know what the other party's doing. And this shows up in fraud detection, where multiple banks might want to tell if other banks have people of high risk or they're frauding across, constructing fraudulent transactions across banks. And so we'd like to be able to identify those people without sharing the banking information across the bank boundaries. All right, and the last thread that we're exploring is how to make our systems more explainable. And so there are a lot of variations on this. I'm going to touch on just one. We're also looking at explainability and data provenance and data lineage, but I'm going to talk about the kind of AI side of that. And so if I presented this image to a neural net and the neural net goes, well, that's clearly a dog. That's probably not the explanation, or that's not a very complete prediction. You might be like, that looks kind of like a dog, but its body doesn't look quite right. Maybe it's also a bird. When we design our neural net technology, it doesn't really think through or it's not designed to express its thinking process. And so we've been looking at ways to combine advances in artificial intelligence from the present, the neural networks, with some of the more classic ideas in things like decision trees to build out more elaborate decision processes so that we can start to reason about what's going on in our scene by giving a sequence of decisions that led to our conclusion. This is important. We start to think about how you might audit a model or say, look, I disagree with one of your decisions, but otherwise, I'd like to know what happened if you hadn't made this conclusion about a person when, let's say, denying a loan. So having these kinds of processes are critical to enabling advances in AI to be applied to real world problems. All right, so that was kind of a whirlwind tour of some of the cool projects that we're doing. I want to step back and just sort of talk about the impact of these research groups. So the RISE Lab and the AMP Lab before it have been building, not just writing really cool papers, but building real software with impact in industry. And there's in fact multiple multi-billion-dollar companies have been launched from these projects. And some of these software artifacts power the back end of Amazon, Apple, the technologies we use every day are coming out of research projects in these big labs. So that is the story of the RISE Lab. I want to allude to one more thing. There's a really cool new division of computing, data science, and society that's trying to bring a lot of these ideas that we've already heard about today. We're in fact already starting to think about how to make AI systems address problems in sustainability. This is also bringing new educational models together to allow us to teach data science, computer science, machine learning to a much broader group of people. So that is it. Thank you.
Great. Well, Joseph, first of all, thank you. Really interesting work. And also, you're the presenter with the images that most likely to give me nightmares tonight, because that dog bird thing was strange. But I do want to, I did have a question that that one of our participants asked. I thought it was interesting to get your thoughts on. So here we go. So our society seems to have shrinking attention spans. It seems clear that knowledge and understanding of AI or machine learning is going to be essential in the years and decades ahead. Are you concerned that over time, people become more and more dependent on their devices and machines will be more intelligent than the general population? I think I call this the matrix question. Is that future state where we are so dependent on AI to do some of these thinking pieces for us that we are, we're no longer as functional as we used to be?
It's a great question. I like to think of machine learning not as something to replace us, but to make us more capable. AI
Mhm.
it's an enabling technology. I can't compute square roots. In fact, I can't do basic arithmetic most of the time. I rely
Me
on
neither.
computing. I think AI will find its way to solve some of our problems and allow us to embrace new challenges, to be more creative, to take on things that we couldn't have done before. Yes, there are some dangers. I think that the more insidious dangers that are immediately facing us is AI is allowing us to strengthen our opinions, enforce our own biases, and understanding how that works and how to prevent it is a critical challenge that we face. But my hope, my optimism is that AI will allow us to be better, to do more.
You know, we have to move to our next speaker, but I think that when I think about this, I think about things like how YouTube is using algorithms to force feed, you know, the reinforcing messages and things like that. And I think it's such an interesting, your work is so interesting because the possibility is amazing and also a little scary. You know, I hope that you'll, there's a bunch of questions in the Q&A. It'd be great if you could kind of pop through and answer some of those. And thank you so much, really fascinating work, and grateful to have you participate tonight.
Thank you.
Of course. Okay, our final speaker this evening is Dave Rochlin. Dave is a continuing lecturer and the executive director of the Haas Innovation, Creativity, and Design practice, as well as the faculty director, Innovation for Positive Impact program, as well as a Cal alum. He is a consultant, social entrepreneur focused on market-based approaches to social and environmental issues, including deforestation, climate change, corporate social responsibility, sustainability business, and ethical globalization. And we'll be speaking to us tonight about the ethics of AI. So Dave, the floor is yours, sir.
Well, thank you, Howard. Thanks for having me. I've really enjoyed the panel so far. And Joseph, all the cool kids work at the Rise Lab, I know. So I enjoyed hearing what you guys are up to. So as Howard mentioned, I'm Dave Rochlin. I teach at the intersection of innovation and responsible business at Haas. My institute also runs what we call the Inclusive AI Initiative, actually, which is through our Center for Business Analytics. And as Howard mentioned, I'm going to speak tonight about AI ethics, also known these days as responsible AI. And I'm sorry we can't be live. I'm pretty sure wherever you are, the parking is better than around campus, so that we have that going for us. So I start most of my responsible business courses, and as you can tell, I'm not going to have any slides tonight. I start with most of my responsible business courses with an overview of ethics. And the reason is because I have to emphasize that ethics is often not clear-cut black and white, right, as much as we want it to be. There's tons of culture issues. I'm sure many of you are familiar with this, including, you know, the value of business transparency, the role of authority, the idea of caveat emptor, even attributes such as age and education are treated ethically differently by culture. They're definitely not universally weighted. But even so, they're actually, even more important than that, there are actually different philosophical underpinnings to ethics. For example, there's virtue-based ethics, which stresses absolutes, such as thou shalt not steal under any circumstances, right? There's also duty-based, deontological ethics, which is that you judge on intent rather than consequences. And of course, the golden rule basically says, do unto others as you would have them do unto you. This one in particular is actually quite rare among tech leaders, interestingly enough. There's been some great examples that I'm sure many of you have heard. For example, Steve Jobs would not let his kids near an iPad. Google, when they launched Google Glass, their virtual reality glasses a few years ago, would not let attendees into shareholder meetings with that item. And Bill Gates has famously said he keeps his kids off of video games and smartphones because they're addictive. And most of those folks who use data most intensely in business demand the most privacy because they know the potential there. And as a starting point, I have to say, I mean, look, unleashing technologies that you protect yourself from, it's pretty questionable. I think we can all agree on that. But the last sort of the philosophical school that I really wanted to highlight last is the utilitarian view, which is focused on taking action for the greater good, right? The ends justify the means. And tech firms in particular often run on these utilitarian principles, right? The term, we're changing the world, is pretty common. But of course, what's used, what defines as the greater good is a judgment call. And certainly in teaching business ethics, you see more often than not that it's used to justify poor behavior and outcomes. So that's my first point I want to make. Ethics is not absolute, right? And since it's not absolute, letting technology firms arbitrate with what's ethical is kind of scary. Their track record just isn't that great. In his book, Winners Take All, which some of you may have read, Anand Girdhardis described tech leaders as rebel kings and worrisome berets. Basically through disruption, they've essentially replaced our democratic mechanisms for responsible business with their own privatized version of ethics. So that's, they have quite a lot of power in determining AI ethics through their actions. And of course, while Joseph's lab is working on it, machine learning algorithms in particular, are still pretty opaque forms of decision making, right? So this is a big reason why there's concern in AI, because AI's primary role, the primary role of artificial intelligence in business, is optimization. Optimization, as I think as we saw tonight, does a lot of really great stuff, right? So everything from making the photo color balanced as possible and use Photoshop. Adobe has AI doing that for you. Determining when to water or apply chemicals on a farm. Microsoft has software for that called FarmBeat. You get the idea, right? And of course, where to send you next on a website, either to keep the media users more engaged or to sell more stuff. Those are all optimization functions. I loved Jordan's optimism earlier about where this could lead, but optimization in particular is rife with issues, and I'm going to touch on them quickly before we finish tonight. The first, I actually call these the ABCs. So the A in the ABCs is for addiction, right? When we use algorithms, machine learning to optimize, we can easily basically enable addiction by design. Social media is the most obvious example. I think most of us are aware of that. AI-based tools for optimizing engagement and stickiness are really fancy terms for just creating addiction, which of course has led to a growing divide and depression that's pretty well documented. Now you're starting to see this also emerge in other areas, which is a little bit scary. Shopping, gambling, restaurants, video gaming, right? I think in the future, as these tools become more accessible, a lot of companies are going to want to optimize behavior using AI and machine learning. And inadvertently or intentionally for some, they're going to be creating addictive behavior. If you want to learn more about this, I really recommend The Social Dilemma on Netflix. It's a really great documentary that highlights it. The B of the ABCs is bias, right? So whether through trained algorithms or machine learning, the pursuit of optimized decision and profit seeking has a potential for massive bias. It just is an easy example for us to think about. If we replaced our admissions teams at Berkeley with a machine learning driven system, you would immediately bias against first generation college students and Pell Grant recipients because they have historically low graduation rates. And so the success rates would be flagged by the machine and they would probably be ranked lower. You see this more practically now in terms of like redlining, for example, with borrowing and insurance. And there actually is an algorithmic risk scoring system in place for making bail decisions in courts. And it's actually proven that there's a lot of racial and gender bias that gets built in when you try to optimize that way. And the counter argument is that judges are equally biased, but the risk of machine learning use in this way is that it makes the decision engine much more opaque. So the last of the ABCs is the C, which is for the commons, which is from the tragedy of the commons. For those of you who don't know, the tragedy of the commons is an economic dilemma that basically states that in many cases, everyone acting in their own self-interest can end up creating a worse scenario for everyone. In game theory, they call this the prisoner's dilemma. Individual optimization is suboptimal versus cooperation. So in any period of voluntary rationing or the need for shared decision-making, like Jordan highlighted, an optimization algorithm that's designed around an individual user is going to take advantage to the detriment of the whole. Now, this may sound a little bit sort of, science fiction future, but Google, if you think about it, already sends commute traffic into neighborhoods with schools to give advantage to drivers in their commutes. See it all over the place, right? So that in that case, you're placing the advantage of the individual driver by optimizing their route over the interests of the community and having safe schools and safe roads near them. Uber is another example of a firm that's doing this extensively. So anyway, I'm going to wrap paper. So the industry is aware of these issues. They're working more against the bugs in the system rather to handle features like optimization. And the reason why is because it's much harder to confront the inherent conflicts of interest in free market capitalism, right? Optimizing isn't what's best for all of us, but it does make good business. So that's pretty much what I wanted to share. This is a huge, rich topic, but I will send it back to Howard.
Dave, I think what a great finish to all these really interesting talks around this subject. And another bit of media around this. I don't know if you listened to the Rabbit Hole, the New York Times podcast that they did. It's kind of similar to The Social Dilemma. It goes pretty deep, particularly around the YouTube algorithm that was created and kind of how that the unintended consequences of the kind of reinforcing, feed. I have a question here from someone that seems like it may be up your alley. So many industries are leveraging AI to reduce headcount by streamlining operations and delegating communications. Is there anyone at this point, anyone in government, academia, private, evaluating the impacts and ethics of AI on workers, like that kind of automation work? Is that something that's people are out there thinking about?
Yeah, I mean, they're thinking a lot about it. I mean, there's two forms, you're getting it from the top and the bottom, right? So a lot of, robotics and factory automation, for example, there's big concerns over that sort of reducing the entry-level ramp jobs that, bring people into the middle class. But also at the higher level, there's a concern that sort of routine functions, the McKinsey did a study showing how many jobs could be turned over to AI in the next 20 years, which is quite a wake-up call. But I think the counter, I'm not sure I agree with it, but the counter argument is that what we're doing is when we create efficiency, we're creating more productivity and therefore more jobs. And so there's going to be some shifting, as there always is. But the idea is that there is going to be more different jobs available as those jobs disappear. Again, I'm not so sure of that. Particularly the lower wage jobs are the ones that are going to be difficult to replace. And so the more you use AI and automation to relieve that burden, the more that you're putting pressure on, you're basically preventing those on-ramps into, a good middle-class life.
It's such a fascinating topic, and I could pontificate for a long time about, going all the way back to the movie Gung Ho and about how people work more efficiently and do things differently, and that fear of automation, that fear of being kind of classed out. I think it was interesting this year in the presidential election, Andrew Yang in the Democratic primaries is really about that basic income because of that exact question, that you're talking about. Any parting thoughts for us before we wrap up this evening? Oh,
sorry about that. No, I'd be happy to talk about it more. I know we're out of time here, but I think it's difficult because going on the ethics side, you tend to drift a little bit towards what's not working. But there's a lot of exciting things like which in terms of jobs and efficiency and all that. I mean, if you're in a job where you have better data and better decision making, it's not necessarily a bad thing. So I think getting rid of a lot of the efficiencies and things that don't work well isn't bad, but you have to really be careful of the both intended and unintended consequences. My colleagues who actually are more technical than I say, machines don't think, they just do what humans tell them to do, right? And so you have to be careful about what you ask for. My final thought would be like Elon Musk has said this is super extreme, but he's way off on the sort of on the bell curve in terms of thoughts about the dangers of AI. And he said, what if you had a sufficiently strong system and you told it to eliminate spam? Maybe that AI would decide to eliminate, to kill all humans. So I don't think that's going to happen, but you have to be careful what you ask for because whatever you're optimizing it's going to be much more opaque and much more efficient than it's been. Yeah.
Well, thank you, Dave. I really appreciate a really interesting perspective on AI, and so glad that you're able to join us this evening. I want to thank all of our speakers once again. I just feel personally so grateful for the four of them to spend some time with us this evening, take some time out of their evening to share their experience in this subject and to help us all kind of think about this more deeply. The hard part about this is that we don't, being in the virtual spaces, we don't get to all congregate afterwards and pick the brains of our faculty, but hopefully they'll stick around for a couple more minutes and answer some questions in the Q&A. I know that the other faculty have done that for us this evening. Dave, I'm hoping you can take a second to do that as well. I hope you will all join me with a virtual round of applause for our speakers tonight. They did just a fantastic job for us, and I'm so grateful for that. Tonight, we tried to cover just a small piece of work that our brilliant faculty are doing in the areas of artificial intelligence. It's really just, we've only scraped the tip of it. And so I want to once again, I want to thank all of you who are on the line tonight, and incredibly grateful for your generous support of UC Berkeley. It's because of you we're able to have great talks like this, and we have the successes we have is because of your ongoing support. If you are looking for more content, we just wrapped up our first ever virtual homecoming this weekend. Much of that content will be available online at homecoming.berkeley.edu. Those videos are being posted as we speak. We will keep adding those over the next week or so. And also next month's installment of our Virtual Discovery Cal series will be on November 16th, where our theme will be big. And we'll be discussing some of the big things happening in Berkeley, like what's happening in big data, what are the big ideas and big entrepreneurship. Thank you again for your support as generous donors and participating in our talk tonight. Once again, hear it for our great faculty. And I hope you all have a great evening and go Bears.